good day, everyone. And once again, we are back together. All right, and I thought today we'd just look at a bit of financial maths. All right, so if you haven't subscribed, please just do the right thing. All right, now quickly, let's look at the question. I got this from the May June exam, right, the 2023 exam. So let's dive into it. They say to us, we've got a company that bought a photocopier of for 150,000 on the 1st of July. They will use the old photocopier to trade in when they replace in a similar new photocopier in 5 years on the 30th of June, that's in 2027. Right, now they say to us the average rate of inflation over the next 5 years will be 6.5% per annum. They say determine the price for a similar new copier in 5 years. All right. Now, when we look at inflation, we remember that we are always going to use, our formula A is equals to P1 plus I exponent N, right? Of course, the accumulated amount in this case would be whatever the value will be in the future, right? Okay, so we know that the copier today costs 150,000, okay, and that's 1 plus the interest, or rather the inflation rate is 6.5%, right? So remember to divide that amount by 100 rather. Okay, so 6.5% should be 0.065. Okay, that's divided by 100. And of course, we wanted to know how much that will cost in 5 years. All right, so we're just going to pull out our calculator. Right, so that's 150,000. Okay, that's 1 plus 0.065. Okay, and we're going to say to the exponent 5, right? Okay, so that gives us a value of 205,000. Okay, that's 205,512. Okay, in fact, we might as well say 513, right? Because that 99 cent. So let's say 513 rands. Okay, right. So that's how much the copier will cost in 5 years' time. Right, now the second question that they ask us, they say calculate the trade-in value for the old photocopier, right, after 5 years if it depreciates at a rate of 9% on a straight line method. Right, now please remember the straight line method, okay, of depreciation kind of looks like when you are taking higher purchase, but of course in this case with a negative sign, right? So we're going to say A is equal to P into 1 minus I times N. Okay, so remember, if it was on a reducing balance method, it kind of looks like this formula, only with a minus sign, right? All right, so in this case, we know that our present value or our principal amount, okay, is 150. 1 minus, okay, they said 9% per annum. So we're going to divide that by 100 again. So that gives us 0.09, okay. That is multiplied by 5, okay. Right, so again, let's whip out our calculator. That's 150,000, okay, into 1 minus 0.09, okay, times 5. Right, so that means it will cost 82,500. Okay, so which means that right there, book value of the photocopier would now be 82,500 in about 5 years' time. All right, now they say the company sets up a sinking fund to cover the replacement cost rather of the new copier. The fund earns an interest of 7.85% per annum, right, compounded monthly, right? The company made its first monthly deposit on the 31st of July, right? And will continue to do so until the 31st of May, 1 month prior. So you need to note that, right? So this is 1 month prior to the new photocopier being bought. All right, how much should be deposited at the end of each month so that the company will be able to buy the new photocopier? Right, now I want you to think about it. How much do we need in the sinking fund? Okay, so remember, to buy the new copier, we need 205,513, but we would have traded in our old photocopier, right? So which means the amount of money that is needed in the sinking fund would be the difference between the two, what you need, right, versus what you would have traded it in with, right? Sorry, this was 6.1.2. Okay, so let's just say in our sinking fund amount we'll need 205,513 minus 82,500, right? Okay, and of course let's try and find that amount. So that's 205,513, okay, minus 82,500. Okay, so which means that we're going to need an amount of 123,013, right? So that's 123,013. That's the amount that we need in the sinking fund. Now remember, what do we use in this case? All right, we're going to use our future value formula because this is what we are working towards, right? So you know that the future value, okay, that's x into 1 plus I to the exponent n, okay, minus 1 divided by I. All right, so we can do our mathematical gymnastics there. All right, I always prefer to substitute in whatever your method would be. That's still fine, right? Now I want you to please keep in mind, okay, let me substitute first. Okay, so I'm going to say 123,013. All right, we are looking for the value of x. All right, and this would be 1 plus, okay, remember our interest value was 7.85, okay, so divide that by 100, so that would be 0.0785. Now I want you to note that they did say that it's compounded monthly, so that means we're going to divide that by 12. Okay, right, now remember when we talk about n, that would be the number of months, all right, that it has been compounded by. But I want you to keep this in mind. They said we're going to withdraw this amount 1 month prior, right? In this case, if you remember, I'm trying to look for that statement, right? They said 1 month prior, right? So which means at the end of 5 years, it would have been 60 months, right? So that would be 12 months multiplied by 5. That should give you 60, right? But because we are going to withdraw the amount a month in advance, right? 1 month prior. So it means we won't actually have it for 60 months, but we'll have it instead for 59 months. Okay, right? Please keep that in mind. So that's minus 1, right? And divided by 0.0785 over 12. Okay, right, and all that's left for us to do is to do some gymnastics. So I'm going to actually divide this by 1, right? So I'm going to multiply this value by that entire value, of course, and afterwards I'm going to divide by that whole expression. All right, so let's try and do that. Okay, so 123,000 multiplied by, okay, let's say 0.0785, okay, over 12, right? So we've got an answer there. And I'm going to take our answer. Okay, I've just ruined it. I don't know what I just did there. Okay, so 123,013 multiplied by 0.078785, okay, divided by 12. All right, there's our answer there. Okay, and I'm going to divide that entire thing, okay, with that's 1 plus, okay, that's 0.0785. Okay, please just be careful of the calculator work when it comes to this. All right, make sure that you are doing the right thing. That's exponent 59. All right, and that's minus 1. I'm going to close that bracket, and I have to close the second one, right? All right, I get an amount of 1,700. Okay, 1,700, and so X would be 1,715 and 16 cents. All right, so that would be the amount that would have to be deposited into the fund. All right, please just, if you can, just verify that amount for me. Okay, and let me know if you get exactly the same thing. Okay, right. I'm trying to just see if I haven't made any errors. All right, so you let me know if you do get to exactly the same answer when you do the calculation. All right, okay, let's move on to the next question. Right, so they say to us, we've got, they say today Andrew borrowed 200,000 from a bank, right? And so the bank charges an interest rate at 5.25% per annum, compounded quarterly. Andrew will make repayments of 6,000 at the end of 3 months, of every 3 months, right? His first repayment will be made in 3 months from now. How long in years will Andrew will it take rather Andrew to settle the loan? Right, now please, I want you to note, ladies and gents, right? So all that we're simply doing here with Andrew is that it's exactly the same principle of, you know, just taking a loan. The only difference is that instead of him paying on a monthly basis, so if we've got a loan here, we always know that we've got this period that is going to pass, right? Before we start repaying the loan, right? Before we make the first installment. Okay. Now, the only difference here is that Andrew is actually depositing an amount every 3 months instead of every month. Okay. So we want to find out how long it will take for him to actually finish off paying the loan, right? Now, remember, when it comes to loans, ladies and gents, we're always going to use our present value formula. And the reason for that is that, remember, the loan is that amount presently. Okay. But of course, we're going to use installments to try and pay it off. Okay. So we're going to say P, that's going to be X into, that's 1 minus 1 plus I. That's minus n. And please remember, you are given these formulae. Okay, so you really don't need to crack your head, trying to memorize them, right? Now, the loan amount was 200,000, if you remember. Okay, right. So we want to find out, in this case, how long in years. So they said Andrew will pay off the loan in installments of 6,000. Okay, and in this case, we're going to say, right, that's 1 minus, that's 1 plus. Okay, remember, it is, what was our interest? That was 5.25, right? Okay, that's divided by 100, so that's 0.0525, right? Now, remember that Andrew is paying, right, quarterly, right? So that means that that will be divided, our M value is 4, right? And in this case, if n is the number of years, remember that she is paying 4 times in every year. So this is going to be minus 4, and n would be the number of years. That's n times m. Okay, so divide all of that by 0.0525 over 4. Okay, right, so all that's left for us is to do some gymnastics. Okay, so again, this over 1. Okay, so what I'm going to do is multiply, okay, right, the 2 together, and we're going to try by all means, right, to isolate that entire term. All right, so let's do that for ourselves. Okay, so I'm going to say that's right, 200,000, okay, multiplied by, okay, 0.0525, okay, over 4, right? Now I've got that value over that side. I'm going to divide it by 6,000. Okay, so divide that by 6,000. Okay, right, now I want you to imagine that now we've got that bracket that is left all on its own, right? Okay, so we've got 1 minus, sorry, 1 minus that entire thing, 1 plus 0.0525, all over 4, right? Minus 4 to the exponent n, right? Now, of course, I'm going to take this 1 to the other side, right? And remember, when I take the 1 to the other side, it becomes negative, right? So I'm going to say minus 1. Okay, so that's minus 1. Okay, I get negative, so that's minus 0.5625, right? If I've removed this 1 here. Right, so if I multiply both sides by negative 1, that will remove or get rid of that negative. Now, ladies and gents, all that is left for us to do, okay, is to use logarithms. Okay, so I'm going to introduce logs on both sides. So the log of that entire expression would be equal to the log. Now, why am I introducing log? I want to drop that down, right? So this will be equal to minus 4n, the log, all right, times the log of that entire expression, 1 plus 0.0525 over 4, right, which is equal to the log of 0.5625. Okay, right, and of course I'm going to divide both sides by that expression, the log of 1 plus 0.0525 over 4. Okay, what I do on the left, I do on the right, and of course divide by 4 later. All right. Right, I know this is a bit mathematically involving. Okay, right, so what I'm going to do is I'm going to take the expression on my left hand side and say the log of 0.5625. Okay, I'm going to divide that by the log. Okay, so the logarithm of 1 plus, okay, we've got 0.0525 all over 4. Okay, over 4. Okay, I get negative 44.12, right? And please remember, so that means minus 44.12 is equal to negative 4n. Okay, because that is cancelled with that. And of course, I'm going to divide both sides by negative 4. Okay, and all right, so divide by negative 4. Okay, and I get n is 11.03. Right, so this is the number of years it will take me, or it will take rather Andrew to finish paying off the loan. So just about 11 years. Okay. Right. I hope that is, quite clear, ladies and gents. Right. And then please, when it comes to the mathematics here, all right, please get used to working on your calculator. Otherwise, from me for now, I'll see you guys again next time. Sharp, sharp.